Okay, so we want to talk about game theory for our little experiment here. Game theory. Game theory, it's important to understand, is not like Adam Smith and supply and demand. When we talk about Adam Smith and supply and demand, we're talking about the interactions that occur between lots of buyers and lots of sellers, thousands of buyers, thousands of sellers. In game theory, we're talking about two countries at war, about five people playing poker, or something like that, a small group interaction that gives us a much different outcome. And in our examples, we're thinking about oligopoly. We're thinking about an industry where there's 3 businesses, 5 businesses, 8 businesses that are competing for customers. So modern game theory comes from a man named John von Neumann, who won the Nobel Prize for economics for doing this. He was hired in World War II to help the Allies figure out strategies that they could pursue for various things as part of the war effort. He wasn't really interested in that, but he did it. His real interest was in playing poker and figuring out how to play poker. The games he looked at were what we call competitive games, which means there's a winner and a loser. There's not games where both sides could win or both sides could lose. Technically, there's going to be a winner or a loser. They also tend to be zero-sum games, which means if the United States wins back an island that Japan had previously conquered, the United States wins the island, Japan loses the island. The United States' gain is equal to Japan's loss. So in his strategy that he's coming up with, it's impossible that we're going to end up where there's all of a sudden 2 islands. We're going to fight over this island and somebody's going to end up with it and somebody's going to lose it. So it's competitive in its zero sum. He did show us in poker, he proved mathematically that if you play poker, you have to bluff. And what we mean by that is in his day, the most common poker that people played would have been a 5-card draw where you dealt 5 cards and then you can give back up to 4 of them and replace them with new cards. You don't know exactly what your opponent has, but for example, if they keep 2 cards and give back 3, that may indicate that they have a pair. If they give you 3 cards, if they give the dealer 3 cards back, or give the dealer 2 cards back and keep 3, now they might have a pair and a high card. They might have part of a straight or a flush, or there's more different things that they might have, but in any case, what they do is giving you information. So what you have to do is occasionally lie. Give 1 card back when you've got nothing, and just pick 1 card, and then bet it like you have something. And your opponent has to realize that they can't tell what your hand is from how you get cards and how you bet. As soon as your opponent can sense something about, and it doesn't have to be a lot, just sense something about how you play or what your cards are from what cards you give back and how you bet, you're done. You're going to lose. So you have to sometimes bet heavy on a good hand, sometimes bet light on a bad hand. You have to play these way. And von Neumann quantified for us, the first person to do this, quantify for us how often you have to do this and what you have to do to be successful. And it has lessons to a lot more than poker when you're playing against someone. Do they know what you're going to do? It applies to football games and basketball games and all this. You want your opponent to not know what it is that you're about to do. Okay? The second big name in this is a guy named John Nash, who also won the Nobel Prize for game theory. And again, there's lots of people who have made important contributions to game theory, but these are the 2 most prominent, perhaps. There's a movie about John Nash, A Beautiful Mind. It's mostly wrong, but it's still a good movie, and you could go watch it if you feel like it. John Nash extended von Neumann's work into what are called cooperative games, which means games where both parties could win or both parties can lose. It might also, his theories also have an effect on competitive games or zero-sum games. But the most interesting part in there is cooperative games. And again, this is small group dynamics. It's not Adam Smith's, big world with thousands and thousands of participants. It's generally about small participants. And when they're small participants, like playing poker, people try to hide their true valuation of things. They try to hide what their hand is. If people are betting in an auction and there's, three people bidding on a painting, they don't want to give away what their true valuation of that painting is, because they're trying to pay less than what they think that painting's worth. And so as soon as they let you know what their true value is, the auction's going to go badly. John Nash gave us some very interesting ways to do auctions that, in fact, try to get people to reveal their true valuation, even though might not be in their best interest. They still end up doing it. Nash also came up with a new kind of equilibrium for us, one that we hadn't thought that occurred. In standard economics, up to this point, equilibrium had always been something good. You knew that if you were at equilibrium, everybody was getting treated right and fair value and blah, blah, blah. Nash proved that you can have equilibria where both parties are not where they should be or want to be. Both parties may in fact be losing out, and yet neither one of them by themselves can make a change which would improve their position. And we call that Nash equilibrium. So an example of game theory that comes from actually before von Neumann or Nash, in fact, a couple hundred years ago, is duopoly theory, and it comes from a man named Cournot and then another man named Bertrand. If we have a monopoly, we know that's going to be bad for the consumers. If there's 3 or 4 businesses in the industry, that's probably going to be bad for consumers. But it turns out that if you have 2 businesses, which is duopoly, it might be bad for the businesses and good for the consumers. And Cournot's example was, suppose you have a small town and there's 2 wells that people have to go to get their water. And the 2 wells are both charging $1 to go visit the well, and it costs about 10 cents a mile for somebody in town to drive out to where the well is. Well, you're going to go to the well that's closest to your house, right? If there's a cost for you to get out to the well, and the wells are charging the same price, you're going to go to the closest well. That means that if the well on the right lowers from $1 to 90 cents, that's going to take a bunch of people who are now going to find it's closer to go to the well on the right than the left. They were going to the left, now they're going to go to the right. It's a zero-sum game. Every customer that the well on the left loses is a gain of customer for the well on the right. So the well on the left might respond by lowering their price, and they'll go back and forth, and you might just end up with a price of 0, essentially, that they're giving the water away. We used to see this happen in gasoline, that there would be these price wars and the price of gas would fall to 10 cents a gallon. It doesn't happen anymore because they learned how to deal with it. The companies learned how to prevent this from happening. But it's a game where, because it's a zero-sum game, it's a game where the people who are playing it lose and the consumers are going to benefit. Okay? And the question is, how do we get out of this problem? How do we get around the problem of this zero-sum game in duopoly? And we'll talk about that here in a second. So this is an example of something that we call a prisoner's dilemma game. And I didn't write that down here, but you'll hear that phrase a lot in the world as you become econ majors. Prisoner's dilemma. So you see this happening all the time on television, where there's a cop show. We have 2 criminals, which I cleverly called Capone and Dillinger, and we know that they committed a murder. We know they killed this guy, but we have no proof. Everybody on the planet told us, hey, they did this. We need to do something about it. What are we going to do? Well, we're going to drag the two of them into the police station. But we're not going to put them in the same room together. We're going to put them in separate rooms. Now they're the guys who own the wells. We've separated them. They're not able to talk to each other. If they both keep their mouths shut, they both get to go free. However, if you're Capone and you're sitting in that room and the police guy is going, hey, Dillinger's going to confess, you're going to get screwed over here. If Capone confesses, he's going to get a light sentence, like 5 years, and Dillinger's going to go away for life because, in part, Capone's going to lie and say, hey, I didn't really do anything. That guy did it. Dillinger did it. And I was just there. I drove the car or whatever. If Dillinger does the same thing to Capone, if Dillinger confesses and Capone doesn't, then Dillinger makes the deal. He gets the light sentence. Capone goes away forever. If they both confess, now you've got the argument about who did what, and maybe they both get 20 years. The best thing for them to do is to not confess. The dominant solution, the most likely thing for them to do is to both confess. And that's what happens all the time on TV. They're afraid of what the other guy's going to do, and so they both confess. And they get this sentence. It's the dominant solution. It's the most likely outcome, but it's not the best outcome. It's a Nash equilibrium. They're worse off, but they can't, neither one of them individually can make a move that makes them better off. So they're stuck. Okay? The wells, we had this problem in Vegas in about 2005. If you looked at the Las Vegas hotel market in 2005, there was room for one more hotel. We needed one more big property. But there's 5 companies out there. What's going to happen? The prisoner's dilemma says that they should not build it, and one company gets it and the others don't, but nobody wants to be in that position. So they all tried to build it. Caesar's Palace built a bunch of extra towers on Flamingo, started building them. MGM started building City Center. Boyd Gaming started building a hotel called Echelon. We started the M Hotel, private company. Another company started the Fountain Blue. Fountain Blue goes bankrupt. M gets turned into a locals casino. City Center gets downsized. Caesars finishes the outside of the towers but doesn't finish the inside. And it's 10 years before they finish those things off and start making rooms there. The winner is Wynn Resorts. Wynn Resorts starts first. They start building their hotel first. They get what we call a first mover advantage. They finish first. Their hotel is instantly nicely profitable. The other ventures are all not. It's a prisoner's dilemma. They shouldn't have done it. They all were forced to do it. The dominant solution. What they should have done is collude. They can't collude. So what do? They all end up trying to build that one hotel. 6 of them tried to build the one hotel. Wynn gets it done first. They win. Everybody else loses. It's game theory. It's a perfect example of game theory in the real world. So the lesson of all this is that cooperation is better than competition if you're an oligopoly. There's a few oligopoly cooperate. Collude, we would call it, but cooperate. So an example of this that we saw in not really the real world, but people were asked by an economist to send in programs to play a computer game. So you're going to have programs playing against each other in a game. The game is you have 2 artificial intelligence people, and they walk up to each other and they have brown paper bags. The brown paper bags can be full or they can be empty. And you're going to trade bags. And you're going to do this now 1,000 times or 1,000,000 times. You're going to keep trading bags with each other. Okay? The winning strategy was the shortest, simplest program that was entered. And in fact, this game has been played multiple times, and nobody's come up with a better solution than this. And it's a program called Tit for Tat. It starts out by giving its opponent a full bag, and then after that, it gives the opponent whatever the opponent gives you. So if you get a full bag, you get back a full bag. If you get an empty bag, you get back an empty bag, which means you always tie. You never beat the other guy, but you're playing all these opponents over and over and over again, millions of times, and you tie them millions of times, you win. The cooperative strategy wins. When you find an opponent that just wants to feed you full bags, you feed them full bags back, you will both win. When you get somebody who wants to screw you over and not give you anything, then you give them nothing back. You tie. That strategy wins. The strategy of cooperation always beats the strategy of competition in those situations. Okay? An example of this, I had an old friend who used to do this, and it was kind of creepy as an old guy doing this, but strange economists, we do strange things. Suppose you find two little kids out there, 4 and 6, 5 and 7, something like that, brother and sister, and you walk up and you look at one of them in the eye and you say, here's the deal. I will give you $6, but I'm going to give your sister $8, or I'll give you both 5. What do we do? The little kids almost always pick 5 and 5. What they should do, again, is cooperate. One of them should turn to the other and say, give me $1, and then pick 6 and 8, and they're both going to end up with 7. But they'd rather both end up with 5. There is some evidence that there's a genetic sense of fairness, that we're born with an idea of fair treatment, of being treated the same, that it's genetically built into our psychics. So we get upset when we don't think we're being treated fairly, and that's not a learned behavior, it's an inherent behavior. It turns out then that parents can teach kids to get along and to work together by tapping into their sense of fairness, and not by talking to them, but by always treating them in a way which gets them to see the other person. So if you will give things to your kids, and I don't mean you give them toys or presents or whatever, but when there's situations where you get to choose things, your kids feel like they're getting fair treatment in that. They're getting their chance to have their say as much as everybody else is getting their chance. If we always do what my little sister wants, then we're going to end up pissed at my little sister. But if we know that everybody's getting the same number of chances, then we're fine with it. Parents can, by showing kids that they're getting things from their sister, they're getting things from their brother, they're getting things from you, then kids have a natural tendency to want to return that because they have this built-in sense of fairness. So game theory applies to a lot more than business behavior. It also applies to things like parenting. So how does it apply to oligopoly, to the businesses we're studying? Remember that oligopolistic firms are interdependent. What one does affects the other. So game theory applies, and it generally, oligopoly is not a zero-sum game. It's not a competitive game. It's a game where they can work together to their mutual benefit. Coke and Pepsi have an agreement. It's not a written down agreement, but it's an agreement, and Coke and Pepsi are going to work together on this agreement. And by doing it, and again, it's not written down, it's what we call tacit collusion, but they work together. And they work together to their benefit and to the expense of the consumer. So Coke and Pepsi are going to get to charge higher prices, and they're going to get to compete with us on things other than price. They're going to use non-price competition. They're going to be able to charge us a nice set price, or charge the grocery stores a nice set price, not lower their price, not fight each other over sales and discounts, but fight each other over taste and quality and who drinks their beverages. What that means is, in oligopoly though, that we're going to see certain behaviors. They're not going to really innovate. They're going to try to preserve the status quo. You make an agreement with the other firms in your industry. Because you have these tacit agreements, because you have these ways that we do business, you're not going to come up with some new thing and implement some new way of doing business that might potentially violate the agreement. And what you see, if you look at what happened in Las Vegas, we used to be monopolistic competition. We used to have, 30 hotels in the Strip, and they were owned by 27 different companies, and there was no way for them to collude. Each property was different and unique and distinct, and there was something about it you could say to people that. Now you look at the hotels, 80+% of the market, 85% of the market's owned by two companies. 90+% is owned by four companies. So what do you see? Every hotel's the same. Every hotel's the same. They have a Cirque show or they have a residency. They've got a pool. It's got a swim up area at the casino. It's got an adult section and a kids section. They've got a spa. It's the same. Every property is the same. The uniqueness that used to be there's gone. And you expect that in oligopoly because you expect them to collude. So they want to preserve the status quo. They want to be the same. They're going to not take risks. If you own 80% of the market, you've got a way more downside than you've got upside. You're going to not take risks. This can be bad, right? The U.S. car industry, when the oil crisis hit, they tried not to innovate. They tried not to take risks. They tried not to change. They tried to preserve the status quo. And General Motors went from 65% of the market to 15% of the market. So when these new guys come in, when you let new competition in, it can destroy the agreement and destroy the companies that are in the oligopoly. So they're going to do everything they can to keep competition out. So the Ford, General Motors, Chrysler, that owned the U.S. car market in the 70s, the early 70s, tried to keep foreign competition out. They tried to preserve the status quo. They tried to do all these oligopolistic things that you would do, but they're in a prisoner's dilemma situation. They've got to collude. They couldn't collude. They ended up basically getting destroyed by it all. The innovation in an industry, the exciting things in an industry are going to come from what we call the fringe. They're going to come from outside. They're going to come from the players. In the 70s, it was Honda and Toyota. In the car industry, in the 80s, it was Southwest. In the airline industry, in America West. Company that's on the outside that's doing things in Vegas over the last 20 years. It's been the Hard Rock or the Palms. It's been a small property that did interesting and unusual things, and they eventually either get copied by the big guys or bought out by the big guys. But those little fringe players are the ones that do the interesting and exciting things. Okay, so game theory tells us that an oligopoly is going to be wildly different in its behavior than competitive industries where there are lots and lots of buyers and sellers. Oligopolies are going to be unique. And game theory tells us how they're going to act. Okay? So feel free now to go off and do the rest of this assignment and then come to class on Thursday.